thanks again for inviting me onto this podcast. I really appreciate it. Um, this is pretty awesome. Y'all doing this every single week is a big commitment. And spreading all this knowledge and welcoming questions. It's very impressive, and I'm so glad to be a part of it. Thanks again. So I'm going to share my screen. Um, so a couple of last year, sorry. Yeah, so a couple of months ago, I believe it was last year, maybe 10 months ago, I made a video on the truths and lies about 3D printed homes, because it's one of the hottest topics in the construction industry right now, I feel. Like everywhere you look, people are talking about the reality of 3D printing or what problems it can solve. And I was trying to, like I had done with the shipping container video, I was trying to like go past all the hype and see what this technology can actually do, how it really works. And I want to share some of that information in today's presentation, but I want to go past all the information that did post in my video and share with you all what I have learned since then, because I have contacted a lot of companies, had a lot of companies on my podcast, and learned so much about this industry. And it's extremely exciting. It's such a new industry, and there's so much growth involved in it. And people are working nonstop to figure out what potential this has. So it's a very exciting industry. So I think my presentation is going to be a four-part structure. I'm going to talk about what 3D printing is. I'm going to talk about the truths about 3D printing, and then I'm going to share a couple of I'm going to share what some 3D printing companies around the world are currently working on, what problems they're trying to solve, and what niche they're trying to make their mark in. And then we're going to end it talking about my experience staying at a 3D printed home in Austin. Right? So just a brief intro about 3D concrete printing, a very, very oversimplified introduction just to anyone who doesn't know what 3D concrete printing is. So I have like a PLA, there it is. I have a PLA printer in my home here, and many of y'all might have that too. So a 3D concrete printer operates in a very similar fashion to like a home printer, if y'all have like played around with that. 3D printing is basically an additive manufacturing technique. Instead of taking material away, like a subtractive technique, it adds material. It prints material layer upon layer to create a three-dimensional structure. So the main steps in a 3D concrete printing process is you start with the 3D model that you have made in some version of a CAD software, whether it's Revit or AutoCAD or Rhino, Grasshopper, whatever software you prefer to use. You come up with this 3D model, and then you slice it into layers. So after you slice it into layers, you convert that into what's called G-code. It's basically X, Y, and Z coordinates of every point on the wall. So that information, those X, Y, and Z coordinates are fed to a machine, which tells the printer head, like if we're talking about X and Y coordinates, that's where, like whether it's left or right on, like it's on a single plane. So that tells the printer where it needs to pump out material on a single plane. The Z coordinate obviously is in the vertical direction. So it's telling the printer move up, like after you print a layer, move up to the next layer, print it. So that's the X, Y, and Z coordinates. And the printer itself is, so you all know concrete is cement plus aggregates plus water. The difference with 3D concrete printing, because all this material is being pushed through a nozzle head, you can't have large aggregates because you're going to clog up the nozzle head. So this is basically a mortar mix and not a concrete mix. So 3D concrete printing is actually like 3D mortar printing. So obviously we are still in the first iterations of this material and of this technology. Right now people are adding like strength to the mix by using fiber, like reinforcement, or all sorts of other like substitutes for regular aggregates, and they're trying to see what else can we use other than mortar, because mortar by itself is obviously like it's energy intensive. So by adding aggregates to it, you could reduce the amount of cement in the concrete mix. But anyway, so these are the main steps in the 3D concrete printing process. Now, the printer itself, there are two main types of printers. One is a gantry system, which consists of these 4 vertical towers that support a horizontal system on top. So this system up here is basically called a gantry. And I'm sorry. And the nozzle head here can move sideways like X and Y. And then this whole rig up here can move up and down. That's in the Z direction. The other type of system is a robotic arm. So that sits in one location. And this, like, robotic arms are used all around the world for all sorts of things. Like on cruise ships, they're used to make drinks. So over here, you're using the same robotic arm, just the head is different. You're using a nozzle head over here. And that can move again because of the pivot points. It can move in the X, Y, and the Z direction. So 3D concrete printing can occur both in an indoor environment, like in an enclosed facility where you control the temperature and humidity levels and moisture levels. And in the beginning, like when people first started experimenting with 3D concrete printing, many of the prints were occurring indoors because you have better control over variables, and mortar mixes weren't as, they had like a lower margin of error, basically. But we've learned a lot in the last couple of years, and we are now able to print outdoors. So the mortar mixes are more resilient. So they can be exposed to the elements. And the obvious advantage of printing outdoors is you're saving on transportation costs. You don't have to print it in a facility and then spend money transporting it to the site. You're basically printing on a concrete slab. And once the print is done, your walls and the walls have cured, it's done, it's set in place. All right, so that was the first part of the presentation. We're not taking questions right now, right? We're just going to continue and then talk about it. All right. So let me know if I'm talking too fast. I need to slow down. I can.
Belinda, you're fine. Your pace is perfect. Your content's on point.
Okay. All right. So now this brings us to the second part of the presentation. We're just going to go over some of the common myths that about 3D concrete printing, and things that I've heard a lot of people like regurgitate because of articles that were released, like promoting these kind of myths and hyperbole. And one of them was 3D printed homes can be built for less than $4,000. That's not true. These kind of lies started circulating in around 2018. This article was in 2019. Some companies claim to print a home for $10,000, but when they scaled up, they believed they could bring costs down to $4,000. And that's the problem. Like, this is such a new industry. There are so many variables involved. With every company is using a different concrete mix, and like everyone is just like in an experimental stage, and no one has scaled up. You can't make such claims because they're just unfounded. For example, some of y'all might know this little community that's been printed by Icon 3 Strands in Austin. And the approximate cost of one of these homes is $450,000. They're beautiful homes. I mean, the cost is probably justified considering where they're located and how well they're built. But again, it's not $4,000. And I think the other variable we have to consider is that we have to consider local costs. Like, before this blip in lumber prices, wood construction was probably the cheapest in the US. Or in other places, CMU construction is cheaper, or steel construction might be cheaper. We can't say that 3D concrete printing is going to be the cheapest solution everywhere in the world. Construction is so site specific. There's so many variables involved around the world that there is no one solution fits all when it comes to construction or architecture or engineering. It's site dependent. It's based on culture and traditions and history. And I keep emphasizing that whenever I talk about the complexities of the AEC industry. Another myth is that 3D printed homes can be printed in 24 hours. So these printers print walls and not homes. Like a house or a home has so many other components to it, whether it's like electrical, plumbing, insulation, roofing, pouring the slab before you start printing. There is just so much more to it than just printing walls. And if you talk about, like, if you ever read claims of printing in 24 hours, they are ignoring the setup time to set up this printer, to calibrate the printer once it's on site, and then even the curing time, because obviously you can't print all these layers at once. You have to print a couple of layers, wait for them to cure, to harden, and then they're stable enough to print the next couple of layers. So it takes, printing time is not the same as the construction time to build the homes. They're two completely different things. And companies should be open about that distinction. Another lie or myth, not lie, is that 3D concrete printing will make jobs unnecessary. It's going to solve this worker shortage and we're going to completely eliminate humans out on job sites. I don't think that is true, because yeah, you're automating a part of the construction of walls, but you're still going to have people operating the machines and monitoring it. You're going to have people involved in the setup and the dismantle, and then again, there's so many other components to building a home, whether it's electrical and the plumbing and all that stuff. The printer is not going to automate all the other processes involved. And then there was another point I wanted to say when it came to this. Yeah, okay, here we go. So related to this, to the idea of making jobs unnecessary, this is one of the earliest 3D concrete printing modules that was shown off in Dubai, my hometown. And everyone saw this lovely little pretty picture, polished picture on the right, and was fascinated with it. Like, oh, wow, that whole thing was made by a machine and no humans were involved in it. Well, Cobod showed us the reality. Cobod is one of the biggest 3D concrete printing companies in the world. They showed us the reality of what it really looked like before all the touch-ups, the manual touch-ups. This is what it looked like. Like, you see the striations here on the right and how uneven it is. That was it in its raw form in China. And then it was shipped to the UAE, where they added all these other features. They replaced the glass, smoothened out all the exterior walls. All that was done by humans. So I think humans are still going to be heavily involved in construction, and 3D concrete printers are like, they tackle one tiny element of the entire building. The next and second last thing I'm going to tackle is that 3D concrete printing can solve homelessness. And that really, it bothers me, because that's something that I feel that's arrogance, and it's oversimplifying an extremely complex problem. Like in architecture school too, where we have all these issues that we're presented with, like, come up with this solution that can solve the housing crisis or the homelessness crisis. And a building itself is not going to do that. Like, we need several other industries involved in this extremely complex and extremely disturbing problem. We need, like, whether it's psychiatrists or people assisting in jobs, like job searches, or in healthcare. There's so many issues. Rather than just putting a roof over your head, solving one thing and not addressing all the others is not going to fix the problem. So again, related to this idea of solving homelessness is there's a company printing schools in Africa. And I think it's a noble cause. It's a noble attempt, and I hope it does work out. But I did speak to a local builder in Africa and asked him what his thoughts were on this and whether 3D printing could actually solve the lack of housing that's currently in Africa. And he believed that it didn't, and he proposed some really solid arguments why. And I'm just going to, because I don't have any personal experience like building in Africa, so I'm not going to claim uh, that I'm very knowledgeable about the local construction techniques. So I'd rather just present his views on it. And he said that it's a far more complex problem. Like even if you print these precise walls, it is very difficult to get windows or doors that will fit into the precise openings made by a printer, because there is a large margin of error. He has noticed a large margin of error when it comes to the like I said, the windows or the doors or like any other elements that need to be added to a home. Inconsistency is a big problem over there. And then he was talking about the additional labor needed to bring in generators because of frequent power outages, and then having 24-hour security to make sure that the printer itself is not going to be stolen or damaged. And then he said that shipping the printer in to Africa is going to be a huge hurdle because of bribery and corruption and all that at ports. Getting the machine out of the port to your job site is going to be a huge expense, getting it cleared at the port. And then in addition to that, there aren't any paved roads in all of these areas. So this is a expensive, fragile in a certain way, machine. Like you don't want it to be damaged while it's like driving on dirt roads. So that was one of his major concerns. Yeah. So again, it is such a complex issue that we cannot oversimplify it into, let's just take a printer, plop it in Africa, and hey, we've solved the homelessness issue. We have to make intelligent and really, like, we have to discuss this in more detail. Can't oversimplify the problem. And finally, 3D printing is sustainable. And I think I've made a video on like the hypocrisy of being green and sustainable and how liberally we use that word, and like what does it really mean anymore? I agree that we can cut down construction waste out on job sites if we can calculate the exact amount of mortar mix required to print a home. And so we only bring the amount that we need to a job site. We're not wasting anything. And even when it comes to mixing the mix with water, like mixing the mortar with water, we only mix as much as is needed. So we're not wasting. So in that sense, yeah, I agree. We can cut down on construction waste. That's a form of sustainability. But concrete in itself is not the most sustainable material. I love the solidity of concrete, and I think it's wonderful material. It's helped us tame nature in a lot of ways. But its carbon footprint is a major concern. So that's just an image like, talking about sustainability of using concrete. So this brings me to the third part of the presentation is, so since I made that video, I have talked to a lot of 3D concrete printing companies around the world and asked them what they're doing. And it's really eye-opening, and it's made me appreciate how much innovation is going on in the field and how hard people are working to figure out the potential of this new technology and what we can actually do with it. Like maybe eventually we're not going to be printing homes. Maybe there's a far better application for it, but people are working really hard to figure this out. And so some of the many companies around the world, like Hyperion Robotics in Finland, they are, I think, a bunch of really, really smart engineers that have chosen to use a 3D concrete printer for engineering applications rather than architecture. That they have no interest in printing homes. They have, I think they're printing bases for like electrical towers or like I think footings for buildings or something like that. They're trying to use and I believe one of the one of their proposals use like 75% less concrete for a footing, because they calculated exactly how much concrete would be needed rather than just dumping concrete into a cuboidal form and just having a solid block of concrete. They figured out where concrete was needed and what would be the ideal shape of a footing. And they were able to bring the amount of concrete used down to like, cut it down to 75%. Or 25% of the original form. Another one is Vertico in the Netherlands. Again, really, really smart guys. And when I say guys, I'm including men and women. They are experimenting with different kind of nozzle heads. What's the next generation? What's the most like resilient nozzle head or 3D printed design? Or they're also experimenting in certain mortar mixes, but I think they're trying to refine the 3D concrete printer and nozzle head itself. And then there's companies like 3D Wasp in Italy that decided, hey, let's experiment and see what happens if we use earth rather than mortar mixes or concrete mixes. They wanted to make something more sustainable, like use a more sustainable mix. And they made these two very interesting domes out of local earth rather than concrete. And this is a company I recently visited just 2 weeks ago, Apis Core in Florida. Really, really cool. They have a showroom in Melbourne, and they have put wheels on their robotic concrete printer. So rather than it being stationary, their idea, you can see these kind of looks like a mini tank. But of course, it has these supports so that it's stable on the ground. It's not going to move while it's printing. But their idea is that the robotic arm can print a certain part of the building, then drive off to another area and then print that other area. And they believe that this is a more viable solution in the long run rather than the big gantry system that I talked about earlier, because they think that the gantry system is like when you disassemble and reassemble things, like with IKEA furniture, things just don't fit the same way the second time or the third time. Like things get loose, and it's just like, how many times can you realistically reuse elements? That's their theory. So they have gone down the path of exploring the potential of a robotic arm printer rather than a gantry system. And of course, there is Icon in Austin, one of the biggest and local 3D concrete printing companies. They have gone down a very interesting path, which brings me to the last part of this presentation. Their prints, and it is just, the one word that comes to mind is just refinement. I visited another 3D concrete home in Canada, and I've seen a couple of other 3D concrete printing projects, but Icon is tackling style and refinement in a really beautiful way. And I really respect that. So this was the home that I stayed at overnight last year, I think in November. This is a home in Austin. So the lower part, as you can see, is made of concrete, and the upper part, maybe this will be more useful. The upper part was made with traditional stick building. So they collaborate really well with the architects, with the engineers, and they want to come up with something that kind of makes Austin and the inhabitant really proud. Like once you're in that home, you feel like you're a part of history. You feel like something is different. Like the moment you walk in, it is like just very polished and super quiet because of it's basically a concrete home. And they just take a lot of care in how the home is presented to people. And I really appreciated that. And as you can see here, their prints were not as refined as it is now. You can see by the window, it kind of bulges out. There's a lot of like things that they have improved. Like this is their most recent home. I think it's called House Zero in Austin. I haven't visited this one, but there's significant improvements compared to this earlier home, which they printed 1.5 years ago, I believe. So again, they used a zip system, traditional wood framing for the upper floor, and then concrete on the lower floor. So I'm just going to end it with this slide, and then we can have another like a follow-up discussion. And so Icon, when I visited this Icon home, they teamed up with this company called Positive Energy in Austin. And what I really appreciated about it is they didn't just print the walls and then say, okay, we're done. Now figure out how the house is going to function. They care about how the houses function. Positive Energy really cares. The interior designers really care about what the interiors feel like. Everything was so cohesive and worked so well. It felt like a really polished project. And Positive Energy, especially, I feel like they did a really good job with this. They had an ERV, energy recovery ventilator. So like air was constantly being circulated in the home, but it was so super quiet. You couldn't hear it. Like in my home, I've got like a 25-year-old condensing unit. And so every time the AC kicks on in summer, the lights flicker and you hear this loud noise when the fan starts turning. Nothing like that. It was eerily quiet in this home. It was so beautifully executed. So I just want to say that we talked about the myths about 3D concrete printing, but this is such a new industry and there is so much research and innovation going on. It is an extremely exciting industry to be in. But if I hope that more companies like Icon start teaming up with other companies and engineering companies and architecture companies to figure out the potential and start building better. Like it's not just about printing a home, printing the walls, and that's it, we're done. It's about building better homes. So the walls itself are not going to help us build better homes, but how we work together and start like collaborating with each other, share knowledge and share ideas, and that's how we can build better. Okay, so.
Bravo, Belinda. That was a great presentation, and I really like all of the questions you asked of this, not only materially, but philosophically, and way to expel some of the myths, as some people enjoyed saying lies. So I'm reminded of when solar panels came on the scene and how when they started being manufactured en masse, they were really, really expensive. They were very hard to get. People talked about, the process of the manufacturing being very heavy-handed. And I wonder if we can talk about this not only from all the perspectives you shared, but as a tool with a medium, and maybe that medium as it changes is going to help the tool be less cumbersome and less of a carbon offender. So with that, we have a couple questions in the queue. And the first one is from our Annette.
Good afternoon, everyone. Yeah, the first question was, if I can find my own question now.
I tried to give you a good segue.
You did.
Yeah, because you were asking what the choices for material substitution.
That's it. I found it now. It's easy when it's highlighted in blue. Carbon footprints and cement are synonymous with being in a bad place. What alternatives have we got there to substitute?
So there are a lot of companies around the world that are experimenting with geopolymers. So that's another thing I really like about 3D printing. It's encouraging related industries to step up and try to find new innovations. Like who would have thought that 3D concrete printing would spur innovations in the geopolymer field? Now, again, I'm not an expert in geopolymers. I'm not going to claim to be, but it's basically using like waste material from other industries, that material that just would have been discarded, using that as a structural material in concrete mixes. And that I believe has enormous potential, and has a very low carbon footprint. So companies like Hyperion in Finland are experimenting printing with geopolymers rather than mortar mixes.
Interesting. Yeah, I wonder what the recyclable nature of a building like that would be. I mean, if you recycled a mortar building, at least you can crush it up and add more cement and put it back into a house. I don't know what you do with polymer mixes exactly.
That's a good point, but I think right now they're thinking of these buildings as being having much longer lifespans than the homes we're currently building. So if these homes can last us for, I don't know, 80 years, 100 years or so, that's a huge advantage, right? I mean,
yeah, I agree.
Yeah.
Has anybody used foamed concrete or foamed cement?
Good question. I feel like I saw a headline about that a couple, like as foam as an aggregate, as a mix in it. I'm not
foamed
sure.
is where they add like a dishwasher liquid and you form like an aero bar effect.
Oh, you're talking about like aerated concrete. Now the problem with that is that sort of that what you're talking about with like foamed up concrete, that has to be cured in an oven at really critical temperatures. That cannot be done on site.
Oh, that's autoclave, but there's also a material that you can actually use to backfill trenches and things like that. Or flood fill caverns, and it just has a foaming agent in it.
Oh, okay.
Doesn't need to be autoclaved at all.
Does it need to be poured into a like a mold? Is it dimensionally
concrete
stable?
Normally gets put into a mold, but these 3D houses are making the stiffness so great that they can actually prop up subsequent layers. So I didn't know whether anybody done it with what I call aerated cement.
I think we call it aircrete. It's said in the chat, and I've seen a few people have tried to use aircrete before, but I haven't seen it used in this. But I think it's a great opportunity to fill those cores with a concrete-like substance that adds air in there. My take on this topic is that it's wide open for innovation, and us in the Passive House community is where excellence meets innovation. You know, I mean, I think Joe Lestieberg says that the tip of the sword or the edge of the knife is where excellence and innovation happen. And I think this is where both are combining. And when we take our building science knowledge and try and innovate on something that's up and coming, it's a lot easier to make large jumps in improvements when the project, everything's still being innovative. So if we can figure out a way to insulate these walls and make them airtight and integrate our windows in them, I think it's a great opportunity for Passive House to grow along with 3D printing, but not within the myths of other, you know, that Belinda pointed out. So
sorry, I don't want to interrupt you, but this was the headline I saw a couple of days ago. So ETH Zurich, they're obviously in Finland, extremely smart people over there. They have just come up with a foam 3D printing technology. That was the headline I saw on LinkedIn a couple of months ago. I haven't looked into it, but they claim to be able to cut the use of concrete by 70% by using this foamed concrete.
Pretty impressive then, isn't it?
Yeah.
I would throw them. Everyone's not a big fan of spray foam as an insulation, but maybe as a structural building material in the 3D process, it might be a good opportunity. It might be the gains outweigh the losses of construction. So something to think about. I like that.
Certainly is a smoothing agent.
Right.
One of the more underutilized aspects of spray foam is actually the exterior use of spray foam. So I could see the outsides of those buildings being spray foamed, used as an air barrier and an insulation product, and then maybe coated with either some sort of rain screen or other more durable non-UV kind of product to actually build up. But the beauty of spray foam is that it takes the form of the substrate that it's going on to. But innovation, let's reach out to the spray foam companies, see if they want to innovate with us and figure out a way to make these buildings super insulated, air sealed, and abide by the Passive House standard. Mark, what'd you have to say?
I love that. And of course, when we take this approach that you laid out, Kevin, we're dealing with the principles that we all love, and that's the air sealing, and that's the insulating, and it's adding the additional attributes to this system, right? So I think this community is great for bringing that forward. The other part in this presentation, Kevin, that I liked is, Belinda, you brought up that in construction, there are site constraints that are unique to the project. And I think when you've reviewed those innovations, that's clear based on your experience and insight. And the Passhouse community uniquely identifies with that because of our integration of climate zone, right? And the fact that you also brought up what materials are commonplace in one market are not in another, we can't look past that. And so in referencing to Europe, right, there's so many more fiber plants than there are here in the States. And so I would encourage these connections that are in the printing space here to look beyond the concrete and say, hey, the wood fiber market is poised for growth, and the properties it has can really be taken in addition to this. And the innovation comes forward. Right now, this sounds like a trying process, right? Not something that we're ready to move up to training, but they're trying. And it's great that we're having it here in this gritty world where we're trying to always figure it out. Really pleased with the presentation. Thank you.
Thanks, Mark.
Thanks, Mark. I threw a couple links in the chat, Belinda, some mediums we talked about during the initial run that you did with us. The one is the soy that Tara was using to try to make space habitats. And the other is the unrecyclable plastics that Mav is trying to use. And so some of these mediums are lighter, they use less water, they use materials that can't be recycled or are waste materials, but they're still in product testing, you know? So it's these kinds of materials that hopefully can bring this medium into the foreground, or this tool into the foreground with a lighter carbon footprint. Our next question up is from Lloyd Alter. Lloyd, would you like to unmute?
I think I am unmuted. Yes, I want to say what a wonderful breath of fresh air it was listening to you when I started listening to your podcast a couple of months ago on this. I've been writing about this subject since it started, and I've been called such horrible names and been considered such an idiot for saying that, you know, that basically it's a solution in search of a problem. And the thing is, I have to, you know, with Cuccinelli's wasp dome with clay, I thought that was absolutely fabulous. I loved it. It was truly 3D how it turned into an arch. But when I look at what Icon's doing, you know, that's not a 3D printed house. It's a couple of 3D printed elements of walls with a wood frame box sitting on top of one, and with a mass timber on their beautiful, beautiful Lake Flato house with beautiful curved walls with a mass timber roof structure on top. And, you know, when I looked in particular at your last slide, where I see ground floor 3D printed and a wooden box on top, I say, oh, great. They brought in an extra trade to do exactly what they could have done with wood frame on the ground floor. They've added complexity, and they've added nothing at all, but maybe the ground floor is bulletproof, which you need in Texas these days. I mean, I really, and I'm sorry, I shouldn't make that joke, but I'm honestly still having trouble understanding, am I wrong, or is this actually going to break out and be a meaningful thing someday?
I had the same impressions like when I made that first video last year, but since then I've been able to talk to different companies and figure and learn more about what they're doing, and that has I've changed my perspective on it because of conversations with them. It's made me appreciate how hard they're working on alternative like materials and improvements in the technology. Yes, they've made mistakes, but also this is like the first generation of homes, first generation of printers. People are, like, in my opinion, when we figure out what 3D print is actually good for, probably not even going to be homes. It's going to be
Right.
like another purpose. So that's why I appreciate what a company in Finland like Hyperion is doing. They've said, homes are not for us. We're going to figure out what else this printer can do. And them experimenting with bases of towers, like electrical towers or something. Like maybe that's the true potential of 3D concrete homes, 3D concrete printers, I'm sorry. So right now, there's just a whole lot of experimentation, a whole lot of mistakes being made. But I guess it's only through mistakes we learn the true potential of the technology, right? I've become less cynical after talking to companies. That's
Okay. Thank you.
And I appreciate that optimism, Belinda, because really it's a fantastic tool, and it's got a rapidity and a scalability to it that the potential is endless, right? So if we could get the right medium, I think it would be amazing. So let's see, who's next? Peter Eugene. Peter, would you
Hi,
like
thanks.
to unmute?
Yes, just cracks me up, allspice. Sorry. So my question, living on the west coast of the US, seismically shaky ground, what the practicalities are of incorporating rebar into a 3D printed building, or is it even necessary? I assume it's pretty brittle material, so you probably need to get some rebar in as you're printing. How's that done?
So people do it in different ways. Some companies leave voids in the print, like they have an outer surface and then an inner surface with these voids, and then they fill those voids with concrete after the whole house is done. Other people, and even Icon does this, so most firms do this. They print like 5 layers or something, and then they put ladder, what's it called, like the ladder rebar, you know what I'm talking about? In between those layers, like they stop the printer, put the ladder rebar, and then they continue printing over that. So every couple of layers there is reinforcement.
So still pretty good manual involvement, right? Sounds
Yeah.
like nothing wrong with that.
No, nothing wrong with it. But they're all trying to figure out how to make it work. So
Joint enforcement.
if I had done this presentation last year, they would have been completely different. I would be a lot more cynical about it. I've learned a lot since then. Yeah.
Thanks, Belinda.
Thank you.
Thank you, Peter. Our next question is from Brian Perth. Brian, would you like to unmute and ask your question?
Hey, how are you guys? How is everyone? Thanks again. Fantastic presentation, Belinda. I just had a question regarding all of the slides that you have in there. There's no insulation. I don't see insulation on any slide anywhere. Can you explain how that's achieved, please?
So what they do is they use open cell spray foam that is sprayed in lifts. So they spray a certain height, let it cure, and then they spray another height of open cell spray foam. So that's what most of the 3D printing companies seem to be doing after the entire house is printed and cured.
So do you have an R value on that? And how does that stack up with the PHPP?
I guess it depends on the thickness of the open cell spray foam that's used. I do not have R values on, like for the Icon house in Austin that I stayed at, I don't have R values.
Okay, all right, thank you.
Brian, you had a follow-up question about the PHPP. Did you want to throw that in there?
Just because this is like we're heavily focused on passive house here. So if we're looking for a solution, and like while I gather some of the questions regarding are a bit negative towards 3D printing, and I can understand that, but at the same time, innovation, you know, it's the future. It's as simple as that. Like we need to come up with different solutions, etc., etc. So if we're going to push something like this, then passive house space, as was said earlier, is a great space to push it. Like we're the ones that's, you know, looking to break boundaries, etc. But we can't do it if it doesn't stack up in the PHPP. So if this is not something that we can utilize in a passive house, then is of any use to us at the moment, is the question.
Brian, I think there are even, as we know it, modular and prefab dwellings in the offsite world that come to market that don't meet the pass-fail standard, right? Just as our existing building stock doesn't meet it. And so I think this innovation is to come with that question of what can we do with it, adding, as Kevin mentioned, on the outside of it, right? Because certainly, as you state, it's not going to meet pass-fail standard as it is now. And so it's up to this industry to show, and so that they know, they might not even be aware of pass-fail or the whole modeling digital twin process that we offer.
Okay, understood. Yep.
I
And
think
ju-
it's a new technology, and it's something to keep in mind. We can't ignore it just because it's in its infancy stage. And like you said, Mark, y'all should, or we should, use, like, offer our knowledge to the people in the 3D printing industry and tell them how they could be better, because they're open to change. They're open to improving their ways and using better materials. So let's just work together to figure out if we can use better materials.
One thing to add upon that too is we've had other presentations on the show where they built modular construction and then they did a retrofit on the outside of that, which was, to me, was a great innovation. It's a planned retrofit. So I think we can do the same thing here, or we can talk with these manufacturers of the 3D printed houses and maybe build in a way that we can blow in insulation in those cores or cavities, almost like a 3D printed double stud wall that has a minor thermal bridge going across it. When, that first picture in the intro with Belinda's intro picture, I just looked at those cores and I'm like, I can insulate one of those, but we would have to put in a conduit and be able to blow up and down it. We do it regularly on old retrofit buildings, but it's the opportunity that I think is really there. And then let's keep our eye on the prize of where the grants are for innovation. Technology grants and RFPs are around the corner. And if we can take two up and coming technologies of passive house and 3D printing and put them together, I think we can make an impact. And that's why we're all kind of here. So let's use our nerdness, work with the really great architects that are making beautiful buildings like Icon in Austin. And let's work with the engineers to harmonize our skills and build truly, as close to thermal perfection as we can build. So that's my 2 cents. Where are we, Shannon?
We've got about 4 minutes before we get to our natural break here. I just want to keep everyone aware of that. And, if you haven't met Kevin Brennan before, he always delivers the red door of truth to the industry. So Belinda, in the second hour, I want to talk about if you've ever heard of any blower door tests being on there. And I was putting this time frame on of this constraints of where we're at in time, because sometimes Shannon's under the gun with questions. So I want everyone to know that in 4 minutes, we're going to break away. Go ahead, Shannon.
I think we can jump right now because it's about that time and we've got plenty of room to roam after the after hour starts. And our next question is from Bob in Chicago. So hopefully everybody can hang out for the after hour. And I should even ask Belinda. Belinda, do you have time to stick with us for some more questions?
I have a little bit of time. Yeah.
Excellent. Excellent. Thank you. Bob, would you like to unmute?
Oh, sure, Shannon. Thanks a lot. I've got so many questions that, so first thing is what's the strength of the mortar? Because, and it's the strength of the mortar. And then the next question I have is, are there expansion joints ever built into the system?
So the strength of the mortar really varies. Like Icon has this proprietary mix called Lavacrete, and they claim that it has a strength of 4,000 PSI. And then Cobot has another well, it's 4,000, and on the next page it says 12,000 psi. So I don't know which one to believe. But Cobot has another kind of, Cobot is another Danish company. And they're also one of the largest 3D concrete printing companies in the world. Their mortar mix is also comparable to regular mortar or mortar mixes. It's around 4,000 psi, I believe. Expansion joints. So that's a very good question, because everyone knows concrete is going to crack. So what people do, like Icon, what it does is that it seems to print in sections. It's a very, very smart way of printing. So if they have one wall here, they use floor to ceiling windows as a separator between the next wall. They don't have like just regular like window frames that are plopped into the concrete. But the other, what I've noticed with most of these 3D printed concrete is that they have hairline cracks on the outside. So many of these companies are using an elastomeric paint, has a little bit of flexibility to it, and it bridges those hairline cracks. Those hairline cracks are purely for aesthetics. They don't affect the stability of the concrete and don't affect its strength. But that elastomeric paint is almost vital because you're going to see like hairline cracks on the outside.
Okay, so we deal with a lot of CMU and brick structures in Chicago here, and so elastomeric paints are great, but they only last for about 5 to 7 years if you're lucky in a standard CMU wall. Okay, so consider this: if you're not controlling the condensation and moisture that's within the cells, then the elastomeric paint, you might as well just throw it out the window.
Again, I completely agree with you. It is going to be very interesting to see how these 3D concrete buildings age in the next 5 years or so. They look really cool right now, but I agree with you. It's going to be we're going to learn from their mistakes.
So one last thing is, I'm sorry for interrupting here, but part of our work is trying to get masonry structures to breathe, so we eliminate mold and degradation of the wood fiber that's embedded into them. So in these structures, you're basically building a CMU wall, right?
Yeah.
So, in England, they've tried insulating these hollow structures only to have massive failures with every single one that they ever put insulation into. So that's, and they usually use like a loose fill insulation. Now, if you use an open cell foam, Joe Stiebrick calls that the ping pong ball effect, where it collects water, but water can't get out. Closed cell foam, it's not that great, of a second. So I guess sealing up the interior of these cells would really be kind of an interesting way to go, like almost like creating a vacuum within the cells. But that's a whole nother conversation. That's probably not suited for here.
All I can contribute to that is what I know about the Icon house that I stayed in Austin. The engineers, Positive Energy, put in a dedicated dehumidifier. So because they want to, like you said, keep indoor humidity levels at like below dangerous levels where mold can grow and cause like indoor air quality issues. So they maybe that was a reason, like they foresaw indoor, I don't know, the growth of mold or something inside these walls because they use closed cell spray foam. That's why they used a dedicated dehumidifier. I don't know what all the other companies are using.
Our next question is from Derek Calburn.
Hey there, everybody, and hey, Belinda.
I just talked to you the other week.
Good. That's right. I told you I'd be watching right here. No. So, it's funny, I was related to the concrete. I saw something recently that there's a self-healing concrete somebody came up with, little amoebas that kind of rejoin any cracks that get water in them. They grow in the cracks and re-heal it. But I'm still concerned about the rebar activity and the strength of it. But the question I had was around if you saw in your studies any other types of construction robots that seem to show a lot of promise. For example, bricklaying robots or plastering, painting, anything else that seems like it's got, you know, some real potential, even though it's early.
So I did make a video on bricklaying robots 2 years ago, maybe. There's this company in Australia. It's a huge company. What's it called? So they have this like I want to say pneumatic system, like a suction kind of system. So instead of lifting heavy concrete bricks yourself, you can basically use a suction system, stick it on the concrete block, and then transport it and set it down on the wall, and then it releases itself from the concrete block. And that's one robot that has a lot of potential, I believe. Another one is an actual bricklaying robot, and you can check out my video. I'll send you a link to it after this chat. And it actually lays concrete on, and it puts the mortar in between, and then I believe does it put mortar in between the bricks? I believe it does. I think it puts mortar down, and then it sets a brick down, then sets another brick down and another brick down, and it's been used for schools, like really large, tall buildings too. They used it for a couple of schools around the US. Seems interesting, but to me, it's like, shouldn't we be thinking of a different kind of facade that isn't so labor intensive instead of trying to automate a bricklaying facade? I don't know.
Well, one that helps lift the brick, that makes sense.
That
That's
does,
like
yeah.
any kind of a tool. You know, I think the ultimate dream, it's kind of like 3D printing. You know, the dream is that it's going to print wires, it's going to print everything, right?
The mule, I'm sorry, it's called MULE, Mule Masonry Lift, if you want to look it up later.
Yeah. But I think kind of like I said, 3D printing, the dream is that you can print everything. And I think the same thing with the construction tech. You know, the dream is that you can find something, a robot that's as nimble as a human, to be able to do that kind of steps. So it'll be interesting to see how well that takes off too. You know. So thank you so much for all the research. Yeah, that's wonderful.
But like you pointed out, there's so many trades involved in this. And kind of like, I guess, with the car, but there's so many components that have to be automated and get involved in this. It's just, to me, what I get frustrated with is that everyone's like, it's so simple. If the automotive industry has figured out how to like spit out cars just with using robots, why can't the construction industry do it? And to me, it's like, you can drive a car with relatively few tweaks all around the world. Construction has so many variables. It depends whether you're talking about a home, you're talking about a hospital, you're talking about an office building, and there's so many different types of buildings, so many different constraints. How are we going to like narrow down all these different variables and create like one single solution to fit all those different problems? It's far more complex industry than, I believe, than the automotive industry.
It's very easy to automate cars. They're all relatively the same size. Yeah. They relatively have the same components. Exactly. Yeah, construction has always been that way, wildly different in different areas. And even if the technology changes to manufacture them, I think you have to go about it a different way. Not sure that the 3D printing, I do like watching your videos because I think that you, you know, politely debunk some things, the myths. Pointing out the myths is important.
Yeah. Thank you.
Thanks, Derek. I'm going to ask Reed's question for him because he just left and we bid him a good night. He was curious about, he said, so block is not an air barrier, poured concrete wall is 3D printed concrete a good air barrier? It's a good question, right? So they're layering up everything. Are there gaps? Is someone coming along with an air barrier sheet good and putting it on the inside?
Belinda, I'll jump on this. I think the answer is no. and we don't know that it is until it's been tested. So not unless that's been sent to a lab and tested as an air barrier material, I don't think it could really be considered an air barrier. And even when we do use poured concrete as cast in place concrete, it's not so much the concrete that leaks, it's the connection details. So, like a 3D printed house and the layers that it's done, I could easily see that there might be some imperfections where maybe the reinforcement lies going to the outside. So I do think we would need a secondary air barrier material. But I don't think, to be honest with you, I don't think it's been tested. And if anyone knows of a blow door test that's happened on a 3D printed house, let's talk about it. But that's what the overtime's for.
Excellent point, right? And we're switching climates, don't forget too. So, how much we insulate and whether we have service cavity on the inside for all of our good mechanicals. These are all questions. If we could just 3D print Armatherm, then we could just put the windows right in there. But until then, we've got a lot of questions. Next one up is from Diane Lynn from Proud Ground. Diane, are you still with us?
I am. Good evening, everyone. I'm Executive Director of Proud Ground in Portland, Oregon. We work on really the affordability end of the spectrum of all these issues, and it's been extraordinary watching all of the excitement and information being shared. And thank you, Belinda, because this is very important for us to understand. We are working with a developer in the city of Medford to produce 84 new homes. The plan is to apply 3D printing to the building of these affordable homes. I couldn't agree with you more, and you did a great job of myth busting around the affordability of building them. We're not under no illusion. It's going to take the same amount of subsidy to make them affordable as any other home, and they're not a solution to every problem, and they can't be done quickly. In fact, we're already running into like every other development permit issues. What I'm interested in, and I'm not a technician on this team, you all know so much more, because we would love to achieve both affordability and net zero at the same time. And Portland has a very aggressive clean energy fund, of which we applied for, so we can achieve both permanent affordability for Black, Indigenous, people of color, primarily left behind in the home ownership environment. Belinda, I can't ask you thank you. Can't ask you a technical question, but I do wonder if you, and I could maybe connect with you a little bit more about the team that's working on this particular technology. The key to this one is it's fire resistant. That's the claim. And and it's targeted for survivors of the wildfires of 2020. Talk about climate impact. Hundreds of people lost their homes, and a lot of migrant farmers, a lot of Hispanic families, and we're trying to replace some of those homes with this particular building approach. And have you done any research or know anything about the fire resistant elements of 3D printed homes?
Well, concrete is fire resistant, and yeah, that would be an advantage. But like many people in the chat have been saying, like autoclaved aerated concrete could be may have additional benefits than 3D printed concrete. So we should connect after this. So I'm working on another project up here in Oklahoma on affordable homes, and we're also looking at using 3D printed concrete for that, but the cost of the printer is becoming a major issue. Like, how do you justify spending $1.2 million on a printer when you're trying to sell this to the community as affordable homes? But it's, fire resistance. Yeah, it does provide fire resistance. Of course, most of the roofs of these structures are timber, so that's an issue. There is one, so I keep mentioning Cobot. Cobot is a Danish company. a Danish 3D printing concrete company, and they are looking into pouring the excess concrete and making roofs. So rather than using timber roofs like we're doing right now, or mass timber roofs, or just regular stick built roofs, they're thinking about how can we make concrete roofs to make the entire structure fire resistant. Again, it's just the initial stages. They tested it out on one building in Denmark, but it hasn't been done in the States yet.
We'll check in with you and let you know how the project's going. I know we're breaking some real new ground here, and I'm hopeful that we won't be making all the mistakes on an affordable project like this. There'll be a lot of us. Thank you.
Thank you.
Thank you so much, Diane. And the community is here after the show ends, right? So just because we're only live on Wednesday, this chat that Belinda's even been contributing comments and links during the presentation, which is an art form in and of itself. At any point, Diane, Accelerator is there, and we link you through those people to help support that. And I don't remember my exact question, Shannon, but I think my one before the hour was, Belinda, are you familiar if any of these structures that you've encountered, both visited and researched, do you know if any of these have taken on the blower door testing?
I don't.
Okay.
No. So the problem is that these, like when I visited the company in Canada and then the other company in Florida, they're kind of operating by themselves. Icon is the one that stands out, but they're collaborating with all these other companies. So if anyone's done a blower test, I feel like Icon would have for their House Zero in Austin. Just because they like I said, they seem to be more involved in having like a finished product, having everyone as part of it. But I haven't spoken to them about it.
No, that's great. And I would guess that that development in California, that's part of the code as well, that they're required for the new construction to do the blower door. And obviously we all know the folks in Austin that do the blower door testing. So I think it's up to all of us that are here and our networks to pass that along to these folks, right? And say, we have third-party folks that are willing to do the testing, do the review of the projects, and help target ceiling while the blower door is in action, so that everyone is from.
Thanks, Mark. That's the beauty of Pestomas. Every project gets tested, and every project we instantly know the failures. If it met the goals or didn't meet the goals, and that's nobody gets by without doing the red door of truth, right, Mark? So I agree with that. Belinda, one of the things in the pre-show that I thought was fascinating was you telling your story about how you got into this and why. I think it's a great story that everyone should know, and I'd love for you to share it with everyone.
Okay, sure. So I grew up in Dubai. I was born over there. And then I got my bachelor's in architecture there. I came to the States 10 years ago to do my master's. And I got that at the University of Cincinnati in Ohio. So after graduating, I worked at construction firms and interior design firms and architecture firms across the States, like in DC and San Francisco and New York and then in Dallas. And I was very disappointed with the entire field. Like whenever I proposed a change, well, I was just, every industry that I was working in seemed so reliant on manual labor and so set in their ways. No one wanted to change the way things were done. Like architects were willing to click on the freaking print button 50 times, just sit there, work late, come in on the weekends, just to print a set of drawings. And when I would propose writing a script or something that would automate it. So you could be at home and all your PDFs were generated at the office. It's just a smart way. Rather than working hard, work smart. But I was always shot down. So in 2016, I said, okay, I've spent 8 years in college. I cannot imagine being a CAD monkey when I'm 16. I need to do something different. So I looked into Python scripting and Dynamo scripting, and that's how I started my YouTube channel. I started writing really simple scripts, learning what it means to code, learning Python, and I would share that scripts with everyone, like with the rest of the world, like hoping to hopefully improve the industry in my small, tiny little way. And I became an independent contractor, and I've started working at different firms as a BIM manager. And then eventually, like in 2020, I made that video on shipping containers, and then I kind of pivoted. Like my interest in software automation grew into a larger interest in like automation in the construction industry. What can we do better? And that grew into an interest in building science and material science. What's new out there? Something has to change, because productivity is so low. We're stuck in our ways. We're doing the same thing. We've been doing the same thing for 100 years. What's better? So that's what I try to do in my YouTube videos. I figured out, like with T-studs or something, like, what's the next generation of studs or materials or drywall or flooring, and I try to break things down to its elemental form, and like talk about the pros, talk about the cons. Let's not be biased towards things. Let's just have an open, honest conversation about technologies and products, and like help the whole industry grow. If we're just talking about one side of things and because we're biased towards a certain thing, how is that benefiting the entire industry? It's not. So I try to be like brand agnostic in my videos, and yeah, that's what I'm doing.
If I remember from the pre-show, I think it's because people told you couldn't, right?
Yes. Yeah, like I told you all, I said instead of positive reinforcement, I used like negative reinforcement. People said I couldn't do this, so I said, okay, I'm going to leave the company and try to do it on my own. That's what I did.
And welcome to the community. We really appreciate having you on the show.
Thank you.
I know myself, I'm somebody that said, as a young employee, I was always like, there's always a better way. Why aren't we doing it the better way? Why aren't we doing this? I had a notebook from when I worked at a restaurant of like how not to be a boss, how to treat people. And I keep that and I read it regularly, and I try and be a better boss and a better leader. And everyone in Passive House is their own little leader, because they're leading by excellence. And you're leading in your industry of helping us grow and learning the new technologies. And we appreciate you having you on the show.
Thank you for inviting me.
And I really appreciate how you break things down and you talk about the nerdness, because I feel your nerdness, as an architect. Material science isn't a conversation you can have in an easy environment. But amongst us, I think it's pretty friendly conversations here. But I could personally say
we're all nerds to certain degrees, right?
Belinda, you really are a role model for everyone who feels stuck in what they're doing, and wants to push the envelope, change, make it better, work smarter. And there's a lot of people out there that are in that position. So I appreciate that piece, especially for women in the field. I know that happens more often than we like to admit. And then the other piece is that when you do explain things, you do it so succinctly. You cover a lot of ground very quickly. You're very concise. And then you also, I noticed in your videos, you take the time to link people to where you got your information. Like, this is how I learned how to do my YouTube videos. It was from this video from this other person. So look at my link, look at my notes and go look at that one too. And
yeah, because I'm not a video editor. I don't know about building. Sorry, I don't mean to interrupt you, but like, I'm not claiming to be an expert in any of this. Like, my goal is to learn something new every week and share it with the world. I'm not an expert in 3D printing. I just went out there, talked to people, conducted interviews, and like made a video on it and shared it so everyone else would know what I learned. Yeah.
I have another 3D printing question for you while we've got everybody here, so maybe it'll inspire some more chat. When folks think about concrete and masonry as a whole in terms of a large carbon footprint that is unavoidable when we're looking for really materials that are long lasting, right? And bear the elements, bear fire very well. A lot of these items are non-structural, right? We're using glavel for aggregate now and aero aggregates now. And so there's the potential there. And then tilt-up slabs, there's the potential there. Or non-structural items like cladding or, walkways, pavers, things like that. Have you noticed anyone doing 3D printing offsite for those type of units?
You're talking about like smaller things and not just walls?
Yeah, I think I shared a link to Mava with you, which is a product they're hoping to print with, unrecyclable waste, right? Unrecyclable plastics. And they've gotten through product testing with non-structural items. So they have pavers and you can go to any Home Depot or Lowe's and you can find plastic pavers or foam pavers or substitutes for masonry that are not masonry, right? And so they've gotten through product testing with that piece in the hopes that they will be able to 3D print and do structural. But I'm wondering if there are other companies out there that you see doing the same thing, trying to, incrementally get to 3D printing with a better medium, something lighter that uses less water, less thermal bridging, better insulating.
Like geopolymers is the only thing that comes to mind, which I already talked about. Other than geopolymers, I guess what some companies are trying to rethink the wall, if that makes sense. Like instead of solid mass, let's print only the components that are needed. So in that way, like reduce material usage. That's another form of sustainability.
Are you saying like honeycomb type application, Belinda?
Yes. I guess I'll have to, but yes, exactly. Yeah, using exactly where it's needed. So they're kind of using software to dictate the bone structure. So like if you look at our human form, we aren't made of solid, our bones are not just solid masses. They have material where it's needed. So if you can learn from that and print that, so there's a chair called the bone chair. It's made by Joris Larman, I believe. Joris Larman. So they made a bridge in the Netherlands with 3D
Share your screen
printed.
if you're looking at it.
I'm sorry?
Are you looking at it? Share your screen.
Yeah, sure.
Thank you.
I imagine the pages you have bookmarked, Belinda, are like worth their weight in clicks right there.
I don't bookmark stuff. I just try to remember it. Okay, I'm going to share my screen. Can you see it? Okay, so here, this is what I'm talking about. Joris Larman, he made this bone chair. So it's, again, material exactly where it's needed. So they used this concept for the bone chair on a 3D printed metal bridge, MX3D. In the Netherlands. So it's really cool metal bridge. I'm trying to show you earlier versions. So this was the earlier version of it. So as you can see, they're only using steel where needed. This was, again, an earlier version that didn't work out, which was heavily influenced by the bone chair I just showed you. Instead of solid concrete, just use, instead of solid steel, just use steel where needed. This design didn't work out, which is why they had to go to this design, but it was an attempt. It was a noble attempt.
Beautiful attempt.
Yeah.
We had another question come in chat from Marcy Cleveland. Marcy, would you like to ask a question?
Hey, Belinda. Very, very exciting topic. I've been very excited about 3D printed homes since I saw all the hype about the one that was down in Long Island. So I'm a realtor turned building scientist. So I've put my real estate hat on, and I'm curious, you know, have you ever interviewed any residents who are currently living in 3D printed homes? I'm curious, like, what they think of them in comparison to a conventional home, pros, cons.
The problem is these homes are such a novelty. People aren't staying in them. They are renting them out on Airbnb.
Gotcha.
So the 4 homes in Austin, all of them are Airbnbs. And it makes sense. Like, everyone's talking about it. Everyone's excited about it. Why not make money off of that excitement? So yeah, no one has stayed in them in the long run, but I would assume they're very similar to traditional concrete homes. The one thing I would say is there's this concept called visual fatigue. So if you don't smoothen out the walls, the 3D concrete walls inside, they kind of look like toothpaste or sausage layers, and there's a lot of lines going on. So that might be, if you have too much of those 3D printed walls in your home, it could cause visual fatigue rather than like smoothen walls. It's one of those things that you don't think about, but if you, like you say, if someone lives in it for a long time, they would come across that issue.
Right. I would think hanging pictures and curtain rods would be a pain in the ass.
Yeah. Yes. So Icon came up with a very smart idea because they didn't want people to just like drill holes into the concrete. They use these like picture rails, which you can see in museums. So there's a picture rail running across the top of their walls, and there are thin plastic strands hanging down from those picture rails. So you attach pictures to the plastic strands rather than drilling into the concrete. But it's things like that they make you look for alternatives. It's like you can't just like with drywall, you can just use drywall screws and put in pictures anywhere you want to.
That's an old trick from plaster walls.
Yeah, I think we need to adapt that to all passive buildings. That'll save our air barriers a great deal. We had them for years. Also, Marcy, I noticed on Instagram, you also are now BPI certified. So
I am.
Let's congratulate that.
Yes, I have my analyst, and I just got my envelope 2 weeks ago. I took my field exam, and passive house is on my list, but I have to finish my Earth Advantage Sustainable Home Professional course first because I'm already signed up for that.
Go hang out with Kevin Brennan. He'll bring you up to speed. He's the best teacher in the business.
Yeah, Kevin is the air sealing god. I definitely know that.
Whoa.
Pressure.
Well, Marcy, I don't know where are you on the East Coast? You're in the New York City area?
Yes, I'm in the Hudson Valley.
All right, cool. So reach out to me. I might be doing a blow a door test in the next few weeks, and you have new blow a door skills. You know, you can come show off and learn some things and see what really tight buildings are.
Yeah, I would love it.
Maybe we'll do a construction tech, edition of the blow a door test and see, what my results are. Maybe we'll play a game with the community and see, can you guess the number? Maybe, I don't know. But this is the fun aspect of the community we're in. We'll show you the building. I'll do a video, and then we'll close this without going over, Price is Right style. And then maybe we'll convince somebody to give something away that's really cool. I don't know.
Yeah.
What do you guys think?
Okay.
Give away that Huber hat you're wearing, Kevin. It'll be perfect.
And only if you follow up with us and let us know how it went and share those videos. I want to see if I can't be there.
Well, Shannon, you're always welcome. And, I'm under the gun to make this happen, but, it's part of the process of doing a pre-blow a door test, like finding where the mistakes are. It's something that I think would work magically with this 3D printed home, mask up the windows, and then find where the leaks are, and then critically fill. It's kind of, like my process of doing passive house has kind of been inspired by like Kaizen and all the Japanese manufacturing process of don't fix the problem afterwards, stop the line, hit the Kong line, stop, and let's find out where the mistake is and go right to the source and figure out where it is. And the sooner the better, rather than waiting and just like, oh no, everything's fine. We're gonna pass this door. I think we're fine. Just put drywall up. It's cool. Paint the wall. Spend 500 hours making a level 5 finish. I can afford to take this wall down. Maybe no. Let's find it, seal it, fix it, and do it right. But
I think it means it's time for construction tech to take a road trip to Texas, blower door these houses, and Belinda, I think you have the camera and microphone equipment. Kevin has the blower door. Sean has a helicopter, and Shannon and I have a lot of questions.
Well, for those projects, they might need 2 blower doors, and I just got one too. So, these things might be leaky. You might see some interesting things on these. They might take more than 1 blower door to get the right score.
Sean, these are passive houses. They don't need more than 1 blower door. Come on.
Well, Marcy, congratulations on all your accomplishments. I love that you come from the real estate side of things.
Yeah.
And that you actually know what a HERS score stands for, and that you don't just put a 0 in there because you don't know what the value is. I've seen that happen and gone, wow, look, it's a 0 energy house. Nope. It's just somebody that filled out the MLS and didn't have a value for that. So they put the 0 in.
Yeah.
So awesome to have that background, because you can,
we have a long way to go.
We all do.
I'd love to see the Pearl certification become popular in our end of the market.
So Kevin, I've done that with a house that had gone through a great deep energy retrofit. I Pearl certified it for the sale of the home and didn't need to do it because everything sells like hotcakes around here. So the buyers didn't even look at the information. It's coming down the line. There's some interesting programs that NYSERDA is proposing for possible energy disclosures on home sales and rental units. So I'm very deeply involved with some NYSERDA programs and stuff. And
cool.
But real estate, I mean, realtors have a really interesting position in this industry, and I think they could really make a difference for homeowners if they actually knew what they were talking about. So
Marcy, I don't know if you know, but my thermal imaging camera was used to take a very famous picture. Mark and Sean and Shannon and everyone kind of breaks my chops about it. But that very famous picture of a thermal bridge and like a row house in Brooklyn, and then one blue one, that house was just sold for within like 2 days of being on the market for quite a bit of money. That was a premium on the market. So passive houses are cycling, and I think we're seeing premiums for them in the New York City market. There's another one coming on the market too that's going to set the tone. So hopefully we can now, with comps, say that the New York City real estate market has seen a X, Y, and Z uptick, and when it's a passive house certified project. So hopefully we'll see more people knocking on our doors for demand, because we are definitely delivering a better quality product.
Kevin, do you know about Neville House? It's up here in Stone Ridge, Neville House. So they're not certifying them, but they're doing a passive house performance. But the problem is they're like $1.5 to $2 million. I'm like, nobody can afford that. I mean, we need affordable passive house.
Yes, we need the magic middle. We need housing for firemen, cops, nurses, essential workers, not just the Wall Street executives. But the sad reality is that I look at it a lot like electrification of New York City. The JP Morgan chases, and they get their friends lighting first, and then it's spread like wildfire. And that's how I look at passive houses, that you let those that have the budgets to actually influence the market, and then everyone knows what real comfort is and real luxury is, and then it'll spread, hopefully. I've been at this for 20 years, and I got kicked out of quite a few builders' offices, and now they're calling me in, to actually have conversations about passive house, as opposed to me knocking on their door talking about a $2,500 Energy Star rebate that they can get. But now they're seeing real value in the work and the buildings. But we're not talking about 20% improvements. We're talking about 80 to 75% energy improvements on actual buildings. So
speaking of the thermal imaging camera, I think besides the blower door test, I'd like to see the thermal imaging camera. The construction tech crew head to Texas for a hoot nanny, doing the thermal imaging camera with Belinda. And I also have a challenge for you, Marcy. If Kevin hasn't given that camera back to Sam on any of your projects, perhaps in your MLS listings, you can list the thermal imaging photograph of the things.
Ooh, I like that.
Right? Perhaps use that as a way of distinguishing. Everyone can see a white house, a gray house, a black house, a blue house. But if they see a thermal house, it's going to turn heads. And you can't unsee energy. We know that. So, Sean, you're leaning it in the microphone. Say your piece, brother.
Oh, I got lots to say, but I just wanted to ask Belinda one question because I think, sorry, actually, you know what? I got to hold on because Peter's in the queue. So I got to pause and wait for Peter to ask his question. So Peter,
What a gentleman. Peter, would you like to unmute? Thank you for your patience.
Yes, no problem. Was asking about in engineering, we do structural fine element analysis, and you could use that to minimize materials in this kind of construction. Don't know if that's applicable. Have you any knowledge of it? Can you examine that?
I'm sorry, I zoned out. I'm really sorry. Can you please say that again? My bad. I was reading the chat. I'm so sorry.
Okay, well, good. No, that's a lot in the
Not
chat.
shy, Belinda. Don't worry.
I think Peter is offering his services of engineering fine elements for the printing things. And Peter has an array of different engineering skills. Is that right, Peter? You're offering your service to do the analysis?
Yes, I'd like to travel. So the question is, in mechanical engineering, we use fine element analysis, FEA, for structural soundness. And we have software that tells, just like the thermal imaging software, it shows where stress and strain points are, where it needs to be strengthened or weakened. And could that be applicable to this kind of technology? And
It sounds like it definitely could.
yeah, like the honeycomb idea, like
Yeah,
minimizing
absolutely.
to see that you don't need a whole layer of concrete. You just need that much to get that much structural volume. But yet one wonders about the shear strength of the walls. And like you said, they include soft elements to strengthen it, like Agilia, fiberglass strands in it. So in place of rebar, I can also see that a rebar structure could be set up and two spouts on either side of the rebar could be used to blend the rebar in the middle of the wall.
That's a really, can I share my screen?
Yes, please.
Okay, so this is what I was talking about. I don't know if it's, wait, come on. All right. So this image here, this is what I was talking about. So a regular concrete pad was like a solid cube or cuboid, and this is like what we can achieve with the 3D concrete printer. Is that similar to what you're saying?
Well, I'm actually looking at the lower wall where it would run two parallel around a rebar structure. So you have like more traditional rebar idea, depending what material is used, but you need to strengthen it in shear. Yeah, you have to have a wall that'll stand up and not be blown over, and you need to check how it's going to be stronger.
I'm gonna have to connect with you after this and
Okay,
discuss
I've got
this
it in my
further.
head, but I don't know if I'm articulating
Yeah.
it well.
I'll send you my email address so we can
Sure.
continue this conversation later.
Yeah.
And Randy
So I
Reed
find-
just threw a good link in the chat to add to your conversation.
Okay.
So maybe check that out as well.
Sean's turn now.
Well, I didn't want to take away from the stuff. I just wanted to have a little bit of story time in Seanland because about 6 years ago, I went down the 3D printing house path and was trying to figure out, okay, well, if concrete's an issue with embodied carbon, how do we look at different alternatives? And so I was planning on building a passive house duplex. And so I, working with the University of British Columbia Center for Advanced Wood Processing, they had a 3D printer. And so I actually got my house printed, but we used a wood filament. And I went down the road of like, oh, could we actually scale this, 50 times and do this house out of wood? And then when you looked at the waste factor of it all, I was like, you know what, like waste wood should just be separated into two things. One is the structure should be, reused, kind of like what we see with unbuilders, where they've got some really nice 2x4s that are 110 years old that we could repurpose and prefab. And then the wood fiber should just go into insulation. And then I was like, oh, wait a second. If we're taking wood and trying to grind up to make wood fiber for 3D printing, why don't we just stick to what we're good at, which was prefabricated homes and low embodied carbon insulation. And so quickly with that, really cool. So I have this really amazing 3D printed model of a passive house project that taught me, I'm going back to what I love best, which is the prefab homes that we've been working on for 100 years. And kind of going down that path. And so I love the work you've been doing, Belinda, and it's just fascinating to see. But I also just want to showcase too, the other conference that I was at on Friday was the Passive House Northwest conference that was focusing on prefab and panelization. And again, it was just great to see the community come together. And so within a week now, I've been at 2 conferences, and boy, I miss all you people. It's sure nice to see you all in person. And we hopefully will do all this soon. And so I'm glad that again my embodied carbon of driving my truck is a little high, but I'm glad that locally I've been able to see 100 people in real life than on Zoom. So again, glad that these organizations are coming together. And at the same point, you probably hear in the background is we've got a First Nations group doing an event for the community here that are having their social event. So I'm going to leave shortly to go participate with that, but it's nice to see everyone in virtual form. It's nice to see all of you in person whenever we get this to happen. And again, it's just great that this community is collaborating, sharing. And again, Belinda, we thank you very much for opening up your evening to share your experiences, because you are just an amazing individual.
Oh
and
God. Okay. Good. Thank you so much for the opportunity to share all this with you all. I really appreciate it.
The pleasure is all ours, Belinda, but Mark is now going to stop flattering and start to invite you to play the game.
Yeah, we have a little secret that you haven't heard, Belinda. So this is fun with a PH, right? Always with a PH. If you look at Sean's background and Kevin's background and my background, you see the letters dancing right off. Oh, you're on the spot, aren't you? So we'd like to invite you to read the background in that we have over us, and then when you're done, you're welcome to pass the mic to anyone in the audience. So it's simply following these words, and then pass it to someone. And thank you for being with us this evening.
Oh, thank you. Okay. Passive House Accelerator, construction tech, technical, technique, technology. Okay.
Who are you going to throw it to, Belinda?
Shannon?
Oh, it's you, Shannon.
Do this. Passive House Accelerator, construction tech, technical, technique, technology. I'm going to throw it to Marcy.
Oh, wait. Oh, sorry. I wasn't paying attention. Passive House Accelerator, construction tech, technical, technique, technology. And it's going to Jeffrey.
All right. Just throw it forward.
Hey, everybody. Passive House Accelerator, construction tech, technical, technique, technology.
Throw it to someone in Canada, Jeffrey.
How about Peter?
There you go.
Passive House Accelerator Construction Tech. Technical, technique, technology.
We'll see everyone at the summit on Tuesday. Have a great weekend, everyone.
Thank you, Belinda. Thanks, everyone, for coming. See you soon.
Belinda, thank you for being so bashful when people tell you compliments and how great you are. It's adorable.
Thanks,
But
guys.
your work is good. You're making an influence. You influenced us and you're influencing the world, and keep up the good work.